everyone, Insomnia from UnrealTek.net here with another video for you. Today we will be looking at the start of a new series on programming in C++ using the Unreal Engine 4 API. So today we're just going to look at some basic how to create C++ classes in a blueprint-based project, how to create those actual files easily without having to worry about constructors and destructors and such, and creating the actual files for now, and just a basic few lines and statements of code that we will use to do some basic stuff just to get you knowing how to kind of solve problems when it comes to C++ and creating what you want. So with that said, remember, create your way and let's get started. So we're going to launch Unreal Engine 4.10. I don't have 4.11 installed yet. I want to wait for the first hotfix. So once your editor is launched, go to New Project, and we're actually going to create a blueprint project because for the most part, blueprints for prototyping are great. They're fast and they're easily converted to C++ as long as you don't get too involved in them. But they can be converted to C++ in time. So let's choose the typical, let's go with third person just because everything's easy to see, and it'll be a blueprint project. Let's include no starter content, we won't need it. Let's throw it in a folder and we'll call our project Intro to CPP, C++. So let's create that project. So third person, Intro to CPP, no starter content, blueprint based. So let's create that project. So this is of course the usual setup that you are all used to. I am going to reset my layout for you guys. So we will enable the content browser here, and we're also going to view options. We're going to show engine content, and that will show us engine content so that we can get, well, engine content such as, say, the stock sky sphere, just for example. So anyways, let's create, right now we have no C++, there's no C++ except the engine C++ classes, but let's create one. So what we're going to do is we're going to go File, New C++ Class. And that'll bring up this dialog that says choose a parent class. Now if you've used blueprints for a while, I'm sure you are very well versed in the hierarchy of classes. If you hit the show all classes checkmark, this shows you how these classes inherit. For example, an object is the superclass. Every single class boils down to an object. And then actor is your core object. An actor can be pretty much anything. It can turn into, it can expand, into a HUD, into a light, into all these things here. But anything can collapse down into an object, and for the most part an actor. It shows you the most commonly used ones here. You have a character, which inherits from a pawn, which inherits from an actor, which inherits from an object. You have actor components, which are very useful and we'll be using, which inherit from a primitive component, which inherit from an object. We have a player controller and game mode, which we'll be using, mostly the player controller, which inherits from an object. So let's start with, I think the easiest one will be a simple actor, just an actor. So actually, rather, let's start with an actor component because that will allow us to place this inside of a blueprint. So let's create an actor component. So select actor component in the list, hit next, and we will give it a name under name. So let's call this, or log transform rather, because we're going to look at how to display messages in C++. It's very easy in the standard library C++. It's very easy in blueprints. You just do a print string. Not so easy in C++. But I'm going to show you how to do that as a starting intro to the world of the Unreal Engine 4 API. The path is just fine for right now. If you want, you can make it public or private, and it will go into those folders. but I'm just going to leave it in the core source folder. So log transform, we're going to create that class and it will open Visual Studio 2015. And so this actor component, of course, I'm sure you've used it. It'll be a component that we can add to any actor, so any character, any object, etc., etc., etc. So I'm going to show you guys how to get some details about it. I'm going to show you how to hot reload and compile on the fly without having to close, build, whatever. And I'm going to show you some just basic C++ that you can get started messing around with it. A lot of the C++ API in Unreal Engine 4 has to do with practice, learning, a knowledge of C++, and just experimentation. Now I am going to show you something. If you go to where you have Unreal Engine 4 installed, so if you have your Epic Games folder, under the engine version, engine, and then under documentation, CHM. If you open up API.chm, which is a compiled HTML help file, you will find the entire API. This is great if you're offline like I am a lot. So for example, you search blueprint read write, and you can see that this is a U property by searching through here. And you see, okay, we have U properties like blueprint read write, visible anywhere, category, and it tells you what they do. It's not as great as the online one because you have to manually search, the index is huge, etc. It's not really that well laid out, but it's very, very usable. So I suggest that you make a shortcut to that on your desktop by right click, send to desktop, and this will create a shortcut to the documentation. One more thing I'm quickly going to show you. Let's create a new blueprint very quickly. I'm just going to throw everything except for the player start and the third person character and template label into just arena geometry. Let's drag in, let's search for cube. Take a 1 meter cube here. Let's drag it up so it's on the surface, and let's turn it into a blueprint. So we're gonna hit the blueprint add script and content. Let's create a blueprint called BP underscore. We're gonna use this for logging too. So let's call it logging cube. Create blueprint. And I'm going to go to edit, editor preferences, and I'm going to go show friendly variable names unchecked, because that way you won't get confused between C++ naming syntax and the way Unreal formats names in a friendly way. I'm also going to make sure we don't open in a new window, so we're going to set that as the default. That'll make things easier. Alrighty, so our logging cube, this is where the components we can add are. So you see a component would be something like the leap motion controller. So that's what we're going to make, and it'll come under a category called custom. But we'll get to that. What I wanted to demonstrate, oh yes, I also want to go under editor preferences. Blueprint editor, I don't like how it spawns a default node, so I'm going to uncheck that. So one thing that's very interesting, if you do something like say get actor location, if I can spell, I have to use my laptop keyboard because my USB port broke for my microphone. If you right click on a node like this, you'll notice you can go to code definition, and if you don't already have Visual Studio open, it will open it and it will bring you right to the definition of that. Now the definition meaning the header file, which we'll get into later. But you'll see now we have this entire actor header file, and if we control F to find and go get actor location, you'll see that we have this vector get actor location constant. It's a U function, blueprint callable. So that's basically what you're looking at there, and it tells you exactly what it does. It returns the location of the root component of this actor. And then if we if we open up the C++ version all the way in UE4, I'm not going to do it, but basically you would be able to find the C++ code for that too. Alright, so when we created that component, that actor compiler log transform component, it created these two files for us, log transform.cpp, which is your definition file, and log transform.h, your header file or your declaration file. So this is where you would create every variable. So let's say we wanted to create a new variable. First of all, let's just leave this. It creates everything we need. So you can see it creates a tick component, begin play, it has a transform, etc., etc. in the header file, and in the C++, the actual code, it can tick is true, so it can tick. We have on begin play, nothing happens. On tick, nothing happens. Just very basic. So we're gonna hit Shift S to save. We're gonna go back into our Unreal Engine 4, and we're going to hit compile, and you'll see it recompiles and reloads C++ for game systems on the fly. So if we hit compile, the first time it'll take a minute. I suggest you go Window, Developer Tools, and open up the message log, and I like to dock it here because you will get compile errors, and this makes it easy to see. And we're also going to need Window, Developer Tools, output log. Now, when you're making major changes, it does take a while to compile, and there is ways to make this faster, but if you're just making small changes after the first time you compile, it gets much faster because it creates pre-compiled headers. You may have heard of these before. So as you can see, compile complete, and we go to our message log. Under compiler log, it says it worked fine. Now, if we go to our content browser, you'll see under C++ classes, we have this log transform. So now if we go to our BP logging cube, we can add a component, and you'll see, if we find it under, whoops, I pressed directional light, there should be under custom. If we compile, I'll just search for a log transform. How come that doesn't show up? Custom, there it is, log transform. So we can add this component. So we now have our log transform component, but it does nothing other than we can auto activate it, we can give it a tag, default stuff. So what you may be used to is adding variables to things. So let's add a variable to our log transform component. So let's go back to Visual Studio. Let's go to log transform.h, the header, and let's see how we add a variable. So we have public here, and I'm not going to go over public and private. We're just going to add this onto the next line. So we're going to go U property in all caps, because that's a macro, and then open and closing brackets, and we're going to go blueprint read write, comma, and then we're going to go category equals open and close quotes variables. Now only certain U property arguments such as blueprint read write and category will work in certain situations. You just have to come to learn how they do work. So we've created this macro called U property, and you'll see when we hit enter it creates a tab. So we tab in, which means we're now creating things on top of this U property macro. We're going to create a variable. So we can create, say, an int called test integer, and we're just going to initialize it to 0. So one more thing, if you add a comment here, it will show up. So we can say sorry, my keyboard is very sensitive on my laptop. These variables show up, or show up in the editor in BP's, and this comment does too because of its placement. So we're going to hit Control S to save. We're going to go back into the editor. We're going to hit compile. It should be much faster this time. We're going to go to the message log, compiler log, to make sure we have no errors. Turn off real time. Compile failed. Okay, so what was our issue? So this may confuse you at first. An int should work. Well, you have to do a certain type of int called an int32. So if we save that and compile, and there's things called int16s as well, and we won't get into those today, but you'll notice it works this time. So you can't rely on your basic knowledge of programming. There's specific things to Unreal Engine's API, just like learning on any other API. So now if we go to our BP logging cube and our log transform, you'll notice we have, under the default, we have test int 0. Now let me show you something else cool. If we add a comment above this uProperty macro, we can say this will show up when hovering over the category because of its comment's location. Smiley face. We can save that. And let's change this to blueprint read write and category equals testing. Control S to save, back into Unreal, compile, and you'll see now that when we select this and compile, it's not there anymore. But when we drag it in, drag out, we can get test int. So we can now get that variable. And notice the comment, this will show up when hovering over the category because of its comments location, smiley face. And we can also set it because we set it to blueprint read write, set test int. So that's how you make basic variables for modification in Visual Studio. Now there's certain things, just like the integer, we have an f vector for a vector, so this would be a vector example. You have things such as an f string example, things like that. And if we compile that, I'm gonna not set them to blueprint read write. I was gonna set them to visible. Whoops. Visible any. Whoa! I do not like this keyboard. Visible anywhere. So those are very specific in that those types are needed. You can't just type in vector or string. An f vector and an f string is what's used in Unreal. And so we'll show that very quickly. And this time it will show up in here. So we have our test int, and we can see that. And we didn't get our vector and such, for reasons I will not go into at this moment. Notice, however, since we didn't set it to blueprint read write, we can't get test int. That's strictly for code. Now, of course, you can define variables in your CPP file too, but those are more local in its scope, if you will. One more thing, if you want to define a function, you can do it just like here. Use the example. So we can say this is our example of a function. So we go virtual void test function, or we can just go void test function, and then we'll go to our CPP, our declaration file, and we will go void ulog transform, because that's this class, and then the double colons, and then what do we call it? Test function, open and close brackets, and then it won't do anything, but it is a function. And perhaps we will use that as an example. We can call that in begin play. We can call test function, since it's global, since it's defined in the header function or in the header file. So let's compile and see if we made any errors, which I most likely did. Nope, it's fine. So we're not going to notice anything different. We can't call test function or anything, but you'll notice that it is there. This is now getting called on begin play. So let's look at the logging, what we originally intended to do. So let's go into our test function now that I've explained it, or shown that concept, not explained, shown it in a terrible way, of how to display messages. You can't just go print string. You can, but it's not quite that easy. You notice if I type print string, there is no print string. But what there is UE_log, open and close parentheses, and then there's some arguments. So it takes in, the first argument is the category, like what it's called, so it could be my log category. We're just going to use temp log, and then a comma, and then so you see category name, and then verbosity. So how severe is it? Is it just a message? Is it a warning? Is it an error? And if you go to the API, the API is your friend when you're first learning. We're going to go UE_log. Of course, it doesn't bring up anything, so we're gonna go log, and here's our enum log verbosity. So we can go no logging, it won't show up, fatal, error, warning, display, log, verbose, etc., etc., etc. So we're just gonna do warning. It will print in yellow. So we'll go warning as the verbosity. And then VA_args. So what that doesn't really explain itself too well without the full API going into detail, but it's looking for a text macro, and then you can type in a string. So this is a test message. So let's test it out. So this is our own function. So function test function defined in log transform header file in ulog transform actor component is called in begin play. I'm sure you're all familiar with begin play. So we'll save that. So let's see what happens if it's actually going to call our function on begin play. So calls the log function. We should have called it that actually too. Always use descriptive names, of course, but that goes into programming. I'm just showing you in the intro. We have compile fail, unexpected end of file in macro expansion, line 42. Let's find out what that is. 42. Unexpected end of file. What is it looking for? Expected a. Oh, I forgot. Yes, we have 1, 2. I forgot a closing parenthesis. We'll save that. Go back to Unreal and compile. Since we just added a parenthesis, it'll be very class. And temp log, that is not a log category, we'll just go log. That should work. You can see how tricky C++ is when you're not used to it. And as you can see, log is not good either. We'll try log temp, compile, and compile complete. It's log temp, not temp log. So you can see how picky it can be, especially when I'm working with macros. So we have this log transform on here. It's a component we've saved. It's in our level, so we're gonna go to the output log now. So now when we hit play, see on begin play, it says warning, this is a test message under log temp. You can also log actor, I guess, would have been another one I could have used. So what we're gonna do with this is we are going to display its location in the world, hence log transform. So what we're gonna do is we're going to go, first of all, we need to get the owner that has this component. So we're gonna go a actor, and once it turns blue, we can get more details about it. You can see IntelliSense running, but a actor, and we're gonna go owning actor equals get owner, open and close parenthesis and semicolon. So a actor, so that's class a actor, get owner. Notice it returns a actor pointer, so we need to make this a actor with an asterisk after it to make it a pointer. So we'll save that, and so we now have a actor asterisk owning actor, which gets the owner. So that finds our BP logging cube. To verify this, I'm going to show you how to take our logging a step further. We're going to say the owner is, and then we're going to go %s for string, that's programming basics, and then we're going to put a comma, and our VA args are going to be f's pointer f string, open and close parenthesis, and we're going to put an f string in there, which is going to be that. Now we can't just go owning actor. We can if we can go dot to string, but no such thing exists, it would appear. We can save and try to compile that, but I don't believe it will work. And of course, when you're using pointers, you need to use the dash forward arrow, but there's no toString member function either. So what we need to make is an f string. So let's make an f string called owner string equals owning actor dot toString, and that will have to be an f string pointer. So we'll save that. You'll see left of toString type is a actor, blah 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 blah. So let's compile this new one and see how it works. So 43 is where all the ears are. So owning actor, it's telling us it should be like that. So let's try that. Let's compile, but it's not going to work, of course. What we need to do is we can go get owner toString, toString, and it doesn't exist. Get owner dot toString doesn't exist either. If we go fstring own string equals get owner dot toString, we can try compiling like that, and notice that does not work either. But we can go owning actor dot toString. Once IntelliSense catches up. Oh, we'll make it easy. We will go fstring and we'll just place it down here. We'll go owning actor dot toString. Save, compile, and it will not work because it's looking for an f string and it's getting an actor. So what we need again is an f string temp string equals get owner once IntelliSense catches up, get owner, and then we can go to string. It doesn't exist. We can get actor location. Rather, what we'll do is we will duplicate our code up here and we'll just continue calling member functions. Get actor location, so we can do it like that. So certain things can be converted to a string, but that returns an f string. So we need f string star pointers, of course, because we're using the pointer notation. We're going to call this owner string, or we're going to not do to get actor location. Yeah, first we're going to do f string star name string equals get owner. IntelliSense is very slow while recording. I just want to show you the member functions. So we can search for display because we know there's display name in blueprints. Get human readable name. So get human readable name dot toString. We don't need to do to a dot toString since it already is, we would assume. And if we look that up, we can go right over and it says it returns an f string. So that's perfect. We're getting an error though, get owner. No suitable conversion from f string to f string pointer. So I don't need the pointer in there. However, when we do that, actually we're all good. So now we can put that in here. So we can put inside of our f string here, we can go name str, and that's going to replace the Majolo S symbol with our f string name str. And of course there's %d and %t and all that. But if we compile now, and if all goes according to plan, f vector toString 43 and 41, we're just gonna comment that out for right now. and compile because we're not using that one yet. Left brace was unmatched at the end of, oh, I forgot a bracket somehow. Save. You'll notice how it compiles much faster when you're just making small changes. Alright, so now when we hit play and go to our output log, it says the owner is BP logging cube C1, which if we go cube, that's exactly what it is. We can go in here, we can verify that BP logging cube 1. Perfect. So we have the exact name of it. So we have the owner and we verify that it is attached to our logging cube. So let's go back to what we were doing before. So f string owner string equals get owner get actor location dot to string, and let's replace name string with owner. Let's call it owner location. Owner lock. Save, compile, go to our message log looking for ears, and you'll notice f vector to string non-standard syntax. So we need to use a dereferencing, but this should work in f string non-pointer version. If we compile that, pointer to remember what line, 43, and that's just gonna mess things up, I believe, because I'm doing this improperly. Yeah, so since we don't have any variables initialized in our header file for this, or defined, I'm gonna do this the way I like to. So we're gonna go f vector, which is what a location is, of course. Owner loc vec3 will say equals get owner get actor location. So that returns, if we hover over, an f vector. So that's good. And then we'll go f string owner location equals owner lock vec3 dot to string. So that converts the vector to a string, and then we put that into our MajoloS replacement argument. So let's compile, and we're good to go. So now when we hit play and go to our output log, we get the location of 620, 380, 180, which is where this cube just happens to be. So that's great. We can show where the location is. So that's cool. It's logging the transform, but that's pretty boring. What if we want to move it and log that every single frame, say? Alright, so that'll get called every single tick. It's going to display the transform. Oh, we shouldn't have the owner. The transform, or the location, is, we'll change that, and what we want to do is we want to move it. So let's go every frame. Now we can't just go owning actor, because we didn't set that, we didn't define that as a variable. So let's define it in our header file. Let's go u property, and we'll just leave that empty, and we'll go a actor star owning actor semicolon. We'll go owning actor, we'll go local to save this here, to keep it local. That should be fine. So now owning actor will be able to be used. We'll save in a global sense. Owning actor. Now it comes up, I believe. Yep. Owning actor equals get owner. We want to call that on begin play. So on begin play, we're going to set that variable that we defined in here, that a actor, owning actor, to the owner that this is attached to. And now we can use it in our tick function. So we're going to go owning actor, and we're going to use the pointer reference notation, set there we go, set actor location, and it's going to take in a f vector. You'll see if we hover over it, it can take in an f vector, bool sweep. We really need to do all that. So first of all, our f vector, and then we're going to open it, and you can see there's 12 ways we can do it. We're just going to do the simple one. We're just going to do x, y, and z. So float in x. So in the x, we're going to go say first of all, let's just make some initial variables. Or rather, we can owning actor. I'll show you a little trick. This gets a little long, and there's easier ways. There's ways to clean up this code, but it shows you ways you can do this. Owning actor dot, or rather, owning actor get actor location dot. What is x pitch? I believe. We need this notation. Dot pitch. Where are you? Pitch. Dot yaw. Dot x. Is that what I'm looking for? Yeah. No. Dot pitch. Where are you? Alright, fair enough. Dot x plus 0.1 f. So we'll just add a little bit. And then for the y, we're going to do the same thing. So we'll just copy it. Again, like I said, this gets kind of long, and there's ways to make it shorter, but we'll just do this. And we'll go, instead of the x member, we'll go y, and the z we'll just leave at 0. And that should complete after we close this off. And then it's asking us if we want to do, so we have our f vector, then bool sweep, we're going to go false. And hit result, we don't need to do anything with that. And teleport type, none, so we should be able to leave it just like that. So save and see if we got lucky. Compile and message log for our errors that we'll undoubtedly get. Syntax here, line 36. We need one more bracket, probably 2 more brackets with my luck, but we'll try this. or I could count them. 1, 2, like so should work. Compile. And when we play, we're gonna get an it's not gonna move. I'll tell you why in a second. But we get every single tick now. We get you can see now why it has to be movable, but we get the location every single tick. So let's stop. Let's set that blueprint to be movable. Hit play, and it's moved out of sight. I guess because it's gone under the floor. But you'll see that it is reporting the position every single frame. There it goes, very, very slowly in the X and Y direction. So that's, in a nutshell, how you can report the position of something and move it. So hence why it's called log transform. You can add it to any component and it will print that way. So that's how you print and do debugging essentially. So you just need to get used to the types like F string, F vector, A actor, U pawn, all the different types, and declaring your variables and stuff, and learning the macros, and yeah, it's really just practice after that. So hopefully this gets you guys started in the interest of C++ programming in Unreal 4 using the Unreal API. It is a lot slower than blueprinting, but it is a lot faster in performance, and it's more satisfying in my opinion. So in future videos, when I actually know a lot more about the Unreal 4 API and C++ in general, we'll look at doing some interesting things in C++ that you can't do in blueprints, and we'll also do more advanced things. So to recap, when you create a file, it gives you the stock begin, play, tick component, and the constructor, which we won't get into. It gives you the header, which gives you our three functions: begin, play, tick, and the constructor. And we use the U property and then open and close parenthesis to set variables, global variables that is. And we use pointer notation most of the time to get to things. So our A actor star owner equals get owner, open and close parenthesis, and then you use the dash arrow, the pointer notation, to get actor location or whatever, get actor location, and you can just keep on stretching those over and over and over again. So hopefully, like I said, that gets you guys interested in programming in Unreal Engine 4. It's very slow learning at first, and you're gonna get a lot of compile errors that confuse you, and they still confuse me, the basic ones. But it is very satisfying, and there are some things that you just simply need to do in C++, but it's a good skill just to know how to create those simple C++ components and classes, just so that you can get that knowledge in your brain, so that things make more sense to you when you say read them on the forums or whatever. So anyways, that's it for now, and we will see you guys in a later video when I have time. So that's it for now, and remember, create your way.